Hello, how y'all doing? Ready? The talks have been fantastic. I'm super happy that I was actually able to get here. It's my first Cascadia.js. Been meaning to come for a couple of years. It's been absolutely phenomenal. Unfortunately, after the talk, I'm going to have to walk off the stage and right out to the lift to the airport. So I'm going to miss the party tonight. I hope you all have fun. It sounds like an absolute blast. So I'm James, J.A. Snell, online pretty much everywhere, Twitter, GitHub, Gmail. Feel free to reach out anytime if you want to talk about Node or contributing to open source. I work for these folks. They're a company headquartered on the southern coast of Ireland. It's a tiny little village. You would have no idea that there was an international software company there. There's about 130 of us spread about over 24 countries. They pay me to work on Node full-time. Like literally on the platform itself. And I also manage the consulting team there. So not only do I get to build Node, I get to help go out and teach people how to use it and how to use it better. So it's really exciting for me because I get to see every day the really amazing things that people are using Node for. But I also get to see the the misconceptions or the mistakes that are made. Not from the fault, from the engineering team's faults, but largely due to misconceptions of the programming language, or things that we did not communicate properly about the platform, how it works. And there's a lot of misconception out there about how the Node internals actually function. For the past probably year, whenever a customer comes to our team and they're saying, well, our Node app is kind of slow, we need to figure out why. My first question is, are you using promises? And if they say, yeah, my first response is, you're using them wrong. Because typically, folks are actually using them wrong. And it's not their fault. It's just the promise abstraction. There are some nuances about it and how it interacts with Node and the event loop and things like next tick and timers and all these different things that can really trip some, folks up. So I'm here to talk a little bit about how all this stuff comes together. So a lot of people see Node kind of like this. Some people think it's a toy, right? I can just look at this for hours. I have like 3 of these at home. But it's like you look at it, and it's like, okay, what's happening inside? I'm flipping a switch, something's happening, but I don't quite know what's there. So I'm going to talk about how we can peer in what's going on. And I'm going to talk about how Node itself functions under the covers with regards to the event loop. So what's happening inside? This may be a little bit hard to read, but this code prints a series of console statements to, series of statements to the console, right? Your challenge is to figure out, without running the code, right? And I'll have a link where you can go out and try this. Without running it, try to figure out the order in which these statements are printed. There are a couple promises in here. There is a set immediate. There's a next tick. This new thing called queue microtask, because we didn't have things confusing enough. Set timeout. There's a promise all. There's a lot going on in this thing. So it can be rather difficult to see what is happening. These are pretty much all the ways of scheduling asynchronous activity within Node, right? So we have promise, we have event emitter. Event emitter has been in there from almost the beginning. Async await, which I absolutely love. Next tick, and set immediate, which they actually should have been reversed in the names. The one missing from here is like set interval. And queue microtask is this one we just added a couple of weeks ago. It is similar to promises. Like, when you do a promise.then, right? It does the same kind of task where you can kind of manually add an item there. That only works right now in Node in master, right? So if you're building from Node master or Node 11. So if you try out this code in Node 8 or Node 10, you just have to comment out that queue microtask line there right in the middle. But like I said, your challenge, you can go ahead and grab this. If you want to write that down, start looking at the code, see if you can figure it out. If any of you do figure out the order, without actually running the code, let me know. because I only know of a couple of people within Node, within the Node project itself that could figure it out on the first try. But in order to figure out, to see what this code is doing, in order to be able to reason about it, there are 4 critical concepts we need to know. The first one is the event loop, what it is, and basically how it works. The next one is the next tick queue. All right? This is the thing that the process next tick function interacts with. The third one is the micro task queue. All right? This is the thing that promises interact with. And the fourth is this concept. There's no such thing as asynchronous JavaScript. It does not exist. All right? You can schedule the execution of JavaScript asynchronously, but you cannot run JavaScript asynchronously. All right? Very, very important concept when it comes to understanding what's happening within a node process and how that is performing. So this might be a picture you've seen before. It's a very abstract view of the event loop. Right? It's this thing, it turns around and does stuff, right? But what exactly is it doing? This is a better view, in my opinion. What the event loop does is it's essentially delivering messages, right? So you can imagine, I'm a letter carrier, right? And I have a stack of letters, right, that I need to deliver. So I have one, right? And I'm going to give it to somebody. And I can't just go to the next person and start handing letters out. What I have to do is when I give it to somebody, I have to wait until they do whatever they're going to do with it, right? They read it, they figure out, what response they're going to give. They write out a response, right? And then they tell me that they're done, okay? So then I go to the next person and I can hand them their letter, and then I have to wait, all right? And then I go to the next person and hand them theirs. That is what the event loop does. It takes a queue of messages, callbacks, right? Events that have occurred, and it goes through and hands those off to JavaScript functions to execute. All right? It can only do one of these at a time. All right? One of the really important concepts to understand is that in Node, you have a call stack. So you have the event loop running down here. You have some C++ code, and then you have some JavaScript code, right? Every time the event loop gets a notification, it's going to call through C++ up to the JavaScript, all right? And then when that JavaScript returns back all the way down to the event loop, it can move on to the next task and run the next stack of JavaScript code, okay? Now this is critically important because over here on the side are these 2 little things here. One is the next tick queue, and the other is the micro task queue. When code is running in JavaScript and you call process next tick, it's just going to drop a function into that next tick queue and leave it there. When you call a promise and it resolves to the dot then or dot catch or dot finally, what's going to happen is that function handler is going to be dropped into the micro task queue, and it's left there. Okay? It's not until the thread of execution, that stack unwinds back to that JavaScript C++ layer that next tick queue and the micro task queue is drained. So all of those functions will not be called until control returns back to the C++ layer, from that call. Okay? So we can only execute one task at a time. All of these these asynchronous tasks that are scheduled end up getting queued in the micro task queue or the next tick queue, unless they're a timer, which works entirely different. Timer will run on the event loop, either on the next turn or at some set of milliseconds or seconds as the event loop turns. But still, as you're going through and doing all this scheduling, it still only runs one thing at a time. So when JavaScript is running, the event loop is not. The event loop has to pause whenever it's executing this code, which means you can't collect I/O events. No network traffic is being collected. No network connections are being processed. It's just executing that code. We call this event loop delay, and it's the single most important concept for node performance. All right, this is the thing that will kill your node applications from running. So this is an example. Whenever you're doing any kind of large synchronous activity, right, you're just killing everything. You're killing performance. You're not letting Node do what it does, which is asynchronous I/O. Okay? So again, JavaScript is not synchronous. But here's a trick question. Had to label it a trick question because the answer should be obvious. Just for the fact that I'm asking it, the answer is no. Not all JavaScript in Node runs within the event loop. And this comes as a big surprise for a lot of people. Now here's another question. Does it all run within the same event loop? As of Node 10, no, it does not. We now have proper worker threads. Every worker thread has its own event loop and Node instance running. This is all running within a single process. I'm not going to get into that now, but it makes things significantly more complicated, but a hell of a lot more fun. So this is going to be a blast working with this. Hopefully, workers will come out of experimental by Node 12, and I can't wait. But there are three main phases to Node startup. There's the bootstrap, there's main, and event loop. And folks have some different names for these things. What happens during bootstrap is Node's loading its own JavaScript, right? Who's doing serverless stuff? All right, quite a few of you? All right, who have had problems with cold start times? That's because Node is damn slow at loading itself up. It has a whole bunch of JavaScript that it needs to load, and then it needs to load the user code on top of that, right, which happens during main. During this time, it's loading it all, it's parsing the JavaScript, it's compiling it, and then executing it. And there's a lot of boot up that needs to happen within Node itself to make sure that it's able to run. The event loop is started after main scope exits, all right? And only if asynchronous tasks were scheduled. So this is an example. So we have this bootstrap.js file. Excuse me. And one of the statements here is this console log, right? We have the performance API. This Node timing object gives you some timestamps of when things within Node kicked off or when they completed. This loop start tells you when the event loops was actually started after your code had started running. So in Bootstrap.js, here, this first console log statement, loop start is going to be -1, which indicates that the loop has not actually started. You schedule some asynchronous activity, set immediate. When that runs, you check loop start again, and you'll see an actual timestamp there. So this initial code, this top scope, right, top level scope, this is running within that main scope, right? At this point, the event loop is not running. Why is this important? In this code, if you want to start reasoning about what this is doing and the order of execution, you have to start thinking about what is running within the event loop and what is not running within the event loop. You also have to start thinking about what is running within the microtask queue, what is running within the process next to, what is a timer, and how all of these things relate to one another. It is extremely complicated to visualize, even conceptually, how these things interact with one another. Fortunately, we've built some tools to to start to visualize this. So the first rule of Node.js performance: know when your code is running. Know in each individual function. So the first tool that we have within Node are trace events. Trace events are a file format that came out of V8 and Chrome. Right now it's a JSON format that gets outputted by the engine and by Node whenever significant events happen within the core. And we have to go through and actually implement the code to emit these. We are in the process now of expanding the type of information that can come out of Node through trace events. One of the key bits of information we can get right now is what asynchronous activity is happening over the lifetime of that application. We can use this, like I'll show in just a minute, to visualize the activity happening within that application. The next important tool is async hooks. This is the low-level API, which is what we use to actually emit the trace events to see what is happening. So whenever a new object is created, whenever a callback is invoked, the async hooks API is called. This third one is not actually in core. It's another tool. It's an external tool that my team at Nearform built. It's all open source. It's called Bubble Profiling. I'll show you how this works and how it relates to all this, but it's built on top of trace events. So the first significant tool we have is built into Chrome itself. And this is the Chrome Trace Viewer. It's a very unassuming, simple UI. Maybe a little bit hard to read because of the colors that are there. But it can read this JSON file that is emitted by the node process and by V8. And depending on what categories of trace events you've asked it to emit, you pull this in, and it gives you a timeline of when those things were occurring. So this is looking at that timing file. And we see that there was an immediate scheduled, right? That was the set immediate that we had. And that is a persistent object that exists over time, right? And then at some point, that gets executed. We have 2 of those that are happening here. We have multiple promises. And this will show you the entire life cycle of these things. We have, within Node, these things called tick objects. Those are the next tick things that are scheduled on that queue. We can also see when V8 was actually executing code. And the interesting thing about this is we can actually, if we drill in and see, zoom in on this, you can see it actually gets fairly complicated. We can see the exact transition points when V8 when V8 is done executing the JavaScript code, and when control returns back to that C++ layer, and things like the next tick queue and the microtask queue get executed. This is extremely helpful if you know what asynchronous activity your application is scheduling, for you to know what the actual performance impact of that code is. You can see those transition points. You can see when this big JSON parse that you might have in there, how much time that's taking up, and what else it is delaying. Now, it takes a bit of practice to figure out what's going on in here. And it's not the best user interface. It is evolving over time, but it's extremely useful to see these transition points. All right, so let's go back here. Bootstrap trace events, something we enabled in Core. If you use this command line, you can see, let's see here, you can see exactly when Node itself executes its various Bootstrap phases. So when does it start the event loop? When is it compiling its own code? Those kind of things. So we're going to set up some categories. We're going to do V8. We're going to go Node VM. And we're going to say Node Bootstrap. And let me look at that, but I don't want to give away the order of it. All right, so there we have it. We can come back in here, look at our node trace file. And we can see in here there's a bug in Windows. It's not actually telling me what it should say under this contextify script. It should tell me the exact file names that I was requiring. And that's Node's own library and your code that's running in here. It'll tell you when it was required. It will tell you exactly how long it took to load it, how long it took to compile it, and how long it took to execute it. And then show you the exact ordering of the loading of your dependencies over time. And you can, if you look at that with the async activity information turned on, you can also see that activity occurring relative to turns of the event loop. So you can see exactly when all of your code is being run and exactly how long it took. The async trace events, this is the thing that takes the async hooks information and exports it out to that trace event log. This gets quite a bit more complicated. So if we want to take the same one, and we're going to say node async hooks. Now this is all of this is just built into the Node binary right now. Works for 10 and 11. There's some support in it for 8. There are some bugs in 8. So everybody should be on 10 anyway, so upgrade. All right, so we're going to run this again. We're going to come back here, load this back up. And in here, we see there's quite a bit more detail. This is where we're seeing all of those promise objects, the immediates, the timers, the next ticks, and we can see the execution of these things relative to one another. All right. The trace event viewer is good. It provides a lot of detail. It's really hard to process if you have an extremely complicated application. Just this last week, I was, at a customer. We, in a 20, I think it was a 20-second benchmark of their code, we ran through, and they ended up just in that 20 seconds, they had created something like 15,000 promises, about 10,000 next ticks, and a whole bunch else. The trace event file was massive, and it just killed Chrome when it tried to load load it in the viewer. It's extremely complicated, and there's a lot of data there. So we needed a different way of viewing it. So we created a tool called Clinic. This is all open source. You can get it from npm from Clinic, use Yarn, whatever. And what it is designed to do is help you diagnose performance problems within your application. BubbleProf is one of the tools here, and it's very simple. Clinic, bubble, node. Again, I don't want to give away the result. We're going to let it do its thing for a few minutes. What it's doing right now is it's exporting that file, and then it's going to go through and actually analyze all of that async activity. And then it's going to give you a display of that asynchronous activity. What this is showing you is the aggregate latency caused by asynchronous activity within your application. You can explore this. You can kind of drill down into it. You can see exactly when promises happen. The UI, we're still working on it. Some of them turn out. We have a whole gallery of really crazy artwork from this thing. But what it's basically showing you is how long it took to transition from one asynchronous activity within your code to another. So whereas the trace event, you can see it over a timeline, right? And you can see each of the transition points. What this is going to do is aggregate those and show you exactly how much time in each part of your application Node was spending, Node was doing work, right? Or how much time it was spending waiting for work to be done. Okay? So let me show you, let me ask you this one. Are promises asynchronous? It is a trick question. Do promises execute concurrently? There's a lot of confusion about this. I had an argument with a guy a couple months ago who was just absolutely adamant that promise all executed everything concurrently. The challenge is it doesn't, right? When you have an async function, right, and that async function wraps purely synchronous code, right, then it's just going to execute synchronously. So when you have this promise.all, food and bar, food is going to run completely, bar is going to run completely after it, right? What about promise race? Same thing. Race says whichever one finishes first, give me that, right? Well, if the async functions here are all purely synchronous, you're going to have the exact same effect. Foo, which is a much longer loop, is going to block the event loop. That's going to finish first. And so in this particular case, race is not doing you any good. Now, if those functions actually have asynchronous activity, like this await timeout, then yes, bar will finish first, and the promise race will do what you expect it to do. All right, running out of time, so I'm going to skip ahead. I want to show you this example real quick. So this is a real-world example from an application we profiled just about a week ago. All right, using BubbleProf. This is the high-level asynchronous activity happening in this application. It's a mess because this was very poorly written code. And we can drill down in here, and we can see, well, yep, there's more activity here. Let's see, we can find, there's some promise chains in here, like deep promise chains. This is the code that was creating about 10,000 promises within a 20-second run. This is the one I was looking for. This is extremely poorly written scheduling code. All this is doing is scheduling. This was about 1,000 promises in a single synchronous loop. And then they weren't allowed to execute. And then as soon as the control returned, all that executed all at once, one after the other. And then each of those were also scheduling promises. I could drill down here many more levels. I don't have time to do that. But the point is, in order to be able to visualize and reason about this stuff, the whole reason this is such a mess is the team forgot to think about when their code is being executed. They were wrapping synchronous code with promises, thinking that by sprinkling a little promise magic, everything was going to be asynchronous. Or they're using it for convenience, right? Hey, if we're using promises one place, we have to use promises everywhere. That is a misconception about promises. And if you continually abuse promises that way, then your code is just going to get slower and slower and slower because of the additional allocations of promise, these objects, and all these async resources, and all this scheduling overhead. Doesn't mean that your synchronous code is going to run any faster. Okay, so that's it. Like I said, just wanted to kind of peel back the curtain a little bit, how the event loop runs, how these things work together, and some of the tools you can use to start visualizing this stuff. Feel free, reach out. Instead of J.A. Snell anywhere. If you want to talk about some of this stuff, need some more pointers on kind of how these things are going, or how to make your Node applications faster, just reach out and let me know. Thanks.